Word problem number 6 is back to the fun of related rates questions, and these are the ones that really are the essence of differential calculus, or Calc 1. Sounds better to call it differential calculus. They say the volume of a cube, so let's draw our cube, is increasing at a rate of 10 cubic centimeters per minute. So we don't know what the side is right now, but we know that they all have the same side. We'll call it x. And I know the volume of a cube is x cubed. And they give us the volume is increasing at a rate. So that would be a dv dt, which is 10. And if I want to take the derivative, that should be 3x squared dx dt. Right? Chain rule. We're not doing x, we're doing dt. So we need a chain rule there. Okay. So if I want to find, what do they want? How fast is the surface area increasing when the length of an edge is 30 centimeters? So they actually tell us the length of x here. So we can say 10 equals 3 times 30 squared dx dt. 30 squared is 900 times 3 is 2700. So we'll get dx dt equals 10 divided by 2700. And take a 1 off of that, or a 0 off of that. It would be 1 over 270. We're getting warmer. This is the change in the side length on its own. But that's not what the surface area is, right? Because the surface area is one side of the cube like this, which is x squared. So the full surface area is going to be 6 of those. That'll be 6x squared. So what can we do here? Well, we need to know the change in surface area. Isn't that what they've asked for? They want to know how fast is the surface area increasing. So we want a change in surface area over time. So that would be 12x. I'm going to say dx dt. And we know dx dt. And we know x. I think, yeah, they told us. So we should be able to calculate this. The derivative of surface area for dt is equal to 12 times the length of the side times 1 over 270. We can do some elimination without even doing math. These factors of 10 cancel. So I'm going to get, looks like 36 over 27. Can we do that? We can definitely reduce that, right? It should, well, it's going to come out to 4/3, I think. So I believe we can say that the rate the surface area increases at that size, in other words, dSA dt, the change in surface area per second is equal to 1.33 square centimeters per second. So what we've done here is we've taken a three-dimensional volume, we've took its derivative, used a chain rule to find out exactly how fast the sides are changing. Then we come over to the surface area and apply that fact to find out how fast the surface area is changing. So it's one step at a time. And it all starts with recognizing the chain rule here, because we aren't differentiating with respect to x. It's with respect to time, so you need to chain rule and make sure that's out there. All my students miss that, but this is the correct answer.